Okay, so just a quick review. Day one, we basically learned what a log is, and you could rewrite this as a log. Would you please just take a second and rewrite that as a log? Log base something of something equals something. Make it a log. You should have said log base 5, and then you don't go in order. It's not the x next. You jump to the other side, and then you jump back. You got to get that this does not go in order. Of 8 equals x. Raise your hand if you had that one right. Good. Then, if you rewrite this in a way you can put it in the calculator, it'd be log 8 over log 5. And if you really understand that, you know that these don't have a base. How did it change bases? From having a base of 5 to now it doesn't have a base. So it has a base. It's just the most common base, which is base what? Base 10. And calculators are good at base 10. That's why you change it into base 10, so your calculator can do it. All right. So, there's my blue marker. Next, I could put in a little base 10 if I wanted to. That's a base change from base 5 to base 10. Then the next day, yesterday, we learned that if you have a log and you wanted to do a shortcut to do something like this, first of all, if it doesn't say a variable, you can say equals x, right? Right? Okay. Then I could rewrite this and go 2 to the x equals 8. That's a rewrite where you have a log and you make it into an exponential because there's an x in the exponent. And then you can see the answer is just 3. But I told you a shortcut. Do you remember how I could have got 3 a lot faster? I could have just said that 8 could be written as a what to the what? 2 to the 3rd. And then if you notice that the bases are the same, then the answer is already there. Another one I showed you yesterday. So the answer for this one is 3. Another one I showed you yesterday. Do you get that the bases are the same? This is a base because it has an exponent on it. That's a base because it's the base of the log. If the bases are the same, the answer is already there, and the answer is 12. Yes? All right, so let's say I was going to put this in the calculator. Again, a lot of things about logs are not intuitive. You would assume you'd put in log 5 divided by log 12. You don't. You put in log 12 divided by log 5, which is, I think, what you said, but I'm not sure, so I just want to make sure. Okay, so your next step. What are we doing next? Well, we got to get better with these properties of logs. Like, for instance, do you remember yesterday when I said like that kind of thing? You have to be able to just be able to go, oh, let's think about that. That's a really complicated problem. Log base 5 of the 3rd root of 5 to the 5th. But if you know what you're doing, you can just go, oh, that's just 5 to the fraction power. And that's the answer. Okay? So what is the answer on this one? Yeah, because this is just like log base 5 of 5 to the 5 over 3. The root goes on the bottom, just like in plants. The other power goes on the top. So since this has a base of the log and this base of having a little exponent on it, bases are the same, that's the answer, 5/3. All right. So now we start to get into solving equations where you have a log and you have an x in the middle of the log. Like, for instance, let's say I had this, log base x. I don't know what the base is. Ooh, that's weird. Never seen that before. Of 2 equals 3. Then, number one thing that I said on the first day, so much of this just comes down to, can you rewrite it? This is in log form. Rewrite it in the other form, just called exponential form. Write it so it has an exponent in it. And once you do, it won't be hard to solve. So what is this? What to the what is equal to what? X to the 3rd equals 2. Now, you may not have this one memorized, but do you know how to solve it the rest of the way? Okay. Just get the x alone by putting it to the power of what? 1/3. Did I just do something that gives me a plus and minus answer? No, because this is odd. If it had been even, then I would have had to say plus and minus the answer. All right. So then x is equal to 2 to the 1/3 the cube root of 2. That's not something I'd expect you to know. So I'd just say if you said 2 to the 1/3, that'd be a good enough answer. That's where the x is in that position. I want to give you another one like that, see if you can handle it. Log where there's an x in the base, except I'm going to make it 2x this time, see if you can handle this. Of, let's say, 3 equals 1. Then you can rewrite it. Once you rewrite it, you got a simple little equation. Once you got a little equation, you just solve it. You'll have a fraction exponent. Sorry, well, you'll have a fraction for your answer. Pause for a second. Let me try that one. Okay. Should have said that to the that equals that. You're always going in this little cycle. You go from one side to the other side and back again. 2x to the first is equal to 3. Now, is it just the x that gets to the first? This is important. False. This whole thing is put to the first power. Now, in this case, when you're putting something to the first power, do you get it really doesn't matter much? Anything to the first power just stays itself. But what if this had been a 4 over here? Do you get then it would have been 2x to the 4th, and then it matters if it's just the x or if it's the 2 and the x. So, just so you know, this comes like a little parenthesis, little package parenthesis. So the whole thing gets put to the 4th if I change this to a 4. And it would be 2 to the 4th is 16, x to the 4th. You'd have to get the clump alone, so you get rid of this 2 to the 4th, which turns into 16. All right, so next thing. Could you get that door for us, please? Thank you. Back to what it was before, back when it was just a 1. It's just important that you know that's in parentheses. So whatever that number was, it would have gone on both things. So it's just 2x equals 3, and so then x equals 3/2. No big deal, 1.5. Raise your hand if you had that one right. Okay, good. That's if the x is in the base. What if the x is in the argument? Log base 2 of x equals 3. Then, once again, you rewrite it. And this time, a rewrite pretty much answers it. Rewrite. 2 to the 3rd equals x. Isn't x already alone? Then I'm done. I just have to know what 2 to the 3rd is, which is what? So the answer is 8. Raise your hand if you had that one right. Okay, good. All right. That's the easiest kind, because if the x is in the argument, all you got to do is rewrite it, and it instantly becomes alone. And once it's alone, you just have to like do whatever this says. Okay, then there's the last kind. Log base 3 of 5 equals x. And the weird part about this is you don't rewrite it because it's x is already alone. You get what I mean? X is alone, so I don't need to do anything to it. I just need to know what the heck it is. And in this case, I'd need a calculator because it's log 5 divided by log 3. Or if I had made this number just a little nicer, like let's say 27, to get, again, I don't need to rewrite it. I just need to know, oh, 27 could be what to the what? 3 to the 3rd, and therefore the answer is 3. Okay, so how could I make it a little more complicated? What if I said this equals 2x? It's not super complicated. We just figured out a second ago what this was equal to. That whole thing right there simplifies down to what? 3. Do you get that means 3 equals 2x? So you just divide by 2 and you got it. So if you can figure out a block like this and replace it with just a number, it helps a lot. So let me see if you can handle this one. Log base 5 of 25 equals 3x minus 1. Hint, start by simplifying the left side, and it becomes a nice, simple equation. Mr. G, how'd you start?
Change 25.
I like it. That'll show me easier that the answer to the left side is what? Yeah, this whole thing just becomes 2. 2 equals 3x minus 1. And if you can't handle that equation, we got to move you down a level because you're in honors higher algebra, and this is just simple algebra. Add 1 to both sides. I'm not saying you couldn't mess up because you all make little dumb mistakes, but if you don't know how to solve an equation, it's scary. Divide by 3, divide by 3. X equals 3 over 3, which equals 1. Raise your hand if you add 1. Okay, good. Now, next part is I'd like to actually get your notes file open. So everybody find day 3. Pause for a second while you do that. Okay, so we're going into logs day 3 here. And we're looking at the notes. I'm going to pull up the notebook. You guys pull up the day 3 notes. Okay, so here we are in day 3. And this is just a few little review problems. You remember how if we can make that into a 7 to the something, this will be like super easy because the bases will be the same. Go ahead and try that one. That's 7 to the something. Now I know it doesn't have a 7, but you're 49. That could really be a 7, couldn't it? So you rewrite this 49 as a 7 to the something, and then you'll be really close to having the answer. Obviously, it's 7 squared. So this is log base 7 of 7 to the 2/3. What happened there? The root goes on the bottom. The power goes on the top. So 49 becomes 7 squared. Maybe this will help if I just rewrite it this way. Log base 7 of the cube root of 7 squared. And that hopefully helps you see that it's 7 to the 2/3 power. And then the answer must be 2/3. Okay, just let me stretch your mind for just a second. If we really know that the answer to this is 2/3, do you get if I said all of this was equal to 9a? Pay attention. Turn around. Okay. So this part's 2/3 equals 9a. How would I get the a alone? Do you get what I did? I just changed this in for 2/3 because I figured it out. Now it's just a little equation, but how do I get rid of the 9? You could divide by 9, but there's an easier way. Multiply by 1/9. Good. Why is that better? Because this is a fraction, and fractions play nice with other fractions. Timesing by 1/9 is easier because then the fraction can go with a fraction. Those will still cancel each other. And dividing by 9 would have worked, but you'd have had to have a fraction over a fraction, which are always tricky. So 1/9 times 2/3 would be your answer if this had been 2/3. All right, I'm just trying to say, whenever you see this and you find the answer's 2/3, you should get that that means you can replace this with a 2/3 in whatever problem it's in. And then I could say like 2/3 equals 9a. All right, next one. This is the clump. Get the clump alone. Because you can't get rid of that square root until you got the clump alone. Miss W. What's first? Agreed. Did you get 4? And then you divide it by 2. Did you get 4th root of x plus 1 equals 2? All right. Now, this is important. I have a 4th root in here. Does that mean the answer is plus minus? Did I do a 4th root to both sides? No. So it's not a plus minus. So then, how do I get this 4th root off of there? Remember, it's 4th root. That's exactly the same as if I had said x plus 1 to the 1/4. Some people think it's a lot easier to do it when it's like this. Because then you just say, oh, how do I get the 1/4 off of there? I put it to the 4th. Notice people always say times it by 4. No, we're not timesing it by 4. Times 4 doesn't fix fourth root, but putting it to the fourth power fixes fourth root. So then that cancels that, and I have x plus 1. And did I just do a fourth root to both sides? Nope, I just did to the fourth. It wasn't a fraction power. So 2 to the fourth is 16, and then from there, child of age 11 could probably do this. Subtract 1, x equals 15. Just have to one last step to get x alone. All right, that was a get the clump alone kind of problem. All right, I want you to see, first of all, this one should be able to be done if you knew how to do 4 to the something makes 36, and since you don't, the little thing off to the side in parentheses kind of gives you a hint with calc. Grab your graphing calculator, see if you know how to put that in. Some people do a little thing wrong with the parenthesis and they're going to get the decimal wrong. I want to know who it is. Pause for a second while you try that.
Wait, what's the total?
All right, you're going to have to Google it. All right, so this one, I can't do in my head, but I can go log 36 over log 4, and when people call that a base change, I don't want you to be confused. Because what was its base in the original problem? 4. What's its base now? 10. You changed its base by doing that. Get what I'm saying? You've changed its base. It's still the same thing, it's just written with a different base. And the other thing about that base change that I showed you yesterday is that you can make that base anything you want, but your calculator can only do them 2 ways. With base 10, what's the other base the calculator's good at? Base E. What button is that? So I want you to prove it to yourself. Try it with ln 36 over ln 4. That's a base E, and it'll be the same exact thing as when you did log 36 over log 4. Should come out the same exact decimal. All right, I'm going to pause for a second. So did you get about 2.58? All right, good. Okay, so notice it doesn't matter what base you use. If you had a calculator capable of it, you could use base 7.2. It wouldn't matter because that would scale both your answers either up or down, and it doesn't really matter, but they would go up or down together, and so the ratio when you divide them would stay the same. It's kind of like 4 over 2 is, they're bigger numbers, but it's still the same as if you do 1 divided by, oh wait, I'm wrong. So it's still the same as if you do like 8 divided by 4. They're the same exact ratio. So since this is a divide, that's why this works. If you make the bases bigger or smaller, the answers on the top might get bigger or smaller, but the answers on the bottom are going to do the same, and thus the ratio will stay the same. All right. Then, I just talked about this before, that you can hide the x in either the, what position is that? The base, or in the, what's that spot? The argument, and what's that spot? The exponent spot. Now, people don't think of it as the exponent, but as soon as you rewrite this, 2 to the x, you see why it's the exponent spot. Okay, so the one that we're focusing on mostly for today is if x is down here in the base. And when you do that, you just end up with something like that. Then you got to put both sides to a power. Please don't say, I'm going to times it by 1/3. You don't. You put it to the 1/3. Okay, just like this. You put them both to the 1/3 power. And 3 times 1/3 makes 1. And so you just get x to the 1, and that's what we wanted. And they've left this kind of written a little bit funny, but if you use a calculator to do it, or you just use your brain and say what times what times what makes 8, you get an answer at 2. All right, so let's try this one. Just do a rewrite. Whenever I say rewrite, I mean if it's a log, make it not be a log. Or if it doesn't have a log in it, make it have a log. That's what it's about, is rewriting back and forth between logs and exponents. So, did you say x to the 3/2 equals 27? Because if you did, you're on the right track. Next, I'm going to put it to the what power to get that 3/2 power off of there. That was loud. All right. So we're going to put it to the 2/3. Hold up. Did I just put it to a power that makes me have a plus minus answer? No. All right. I keep on asking you that just to remind you, because sometimes we will, and you got to be careful. All right. This one's not one of those times with the plus minus, so it's just the answer. And this one, there'd be no calcs allowed for, because you can do it in your head. What's the cube root of 27? 3 to the second power. 9's your answer. Now, if your life depended on it, you'd probably check. If this answer is wrong, you're going to like run out of oxygen in your spaceship or something. You'd double check it, wouldn't you? Okay, well, on the test, you don't have that many questions. It's worth taking a second and just checking. How do you check them? You stick it back in right here and see if it's really true. Would 9 to the 3/2 equal 27? Would 9 to the 3/2 equal 27? Square root of 9 is 3, 3 to the 3rd. Yeah, it works. Cool. All right. Moving on to the next one. This one, try rewriting it. We're almost done. If you can stick with me for like 2 more minutes, we'll have it. Okay. On this one, I'm hoping that you said x minus 4 in parentheses. Remember me saying that that's actually in parentheses? To the 3/2 power. Otherwise, you might have stuck the 3/2 just on the 4, and that would have been bad. Equals 8. That to the that equals that. Now, we have to put it to a power. Power of what? 2/3. Is that one you can do in your head? Yep. Cube root of 8 is 2. 2 to the second is 4. Okay. Dropsies today. X minus 4 equals 4. Add 4 to both sides. X equals 8. What if I feel like it doesn't feel right to me? How can I be sure I'm right? Check it. So I'm going to go back and put this 8 up here and see if it actually works. 8 minus 4 is 4. So it says log base 4 of 8 is 3/2. So then I can rewrite that. 4 to the 3/2 should be 8. And I'm going to double check it. Square root of 4 is 2. 2 to the 3rd is 8. It worked! Cool. I shouldn't have worried about it, but good idea to check your work. Okay. So I think this will be pretty much the same exact thing. This will be pretty much the same exact thing. So this gets a little bit more complicated looking. Let's get to this last blue one before the closure slide. If you guys can, like 80% of you guys can do this right, I'm feeling good about this. Try rewriting this puppy. And some of you are going to be too smart for your own good. We'll see if you can understand what I mean when we're all done. Try to get the answer. Some of you are going to be too smart. I'm going to pause. It does say calc on there, so yeah. Okay, just to get you started in case you're stuck, this to the this equals that. So x minus 3 in parentheses to the 4/9 equals 7. And then I got to somehow get that 4/9 fixed. So I put it to the 9/4. To the 9/4. And now I have cancel, cancel. And here's where some people might be too smart for their own good. That's what I mean. Do you get we just put it to a 4th root, and therefore there should be a plus and a minus answer? How many of you actually caught that? Okay, good. Now let's see what we get. Absolute value is what you get. That's what you really get. And then I go 7 to the 9/4 power is some nasty decimal. I need help on that one. You probably used a calculator. What's 7 to the 9/4? 7.9? 79.7. All right. Cool. Now I have to say this exact same thing, x minus 3 equals 79.7, and x minus 3 equals negative 79.7. And guess what? You're being too smart for your own good. Because a kid who never even noticed that there's a plus and minus, would get this problem right, and a lot of you are going to get it wrong. Why? Because I get 82.7 and I get negative 79,876.7, right? But only one of the two of them actually works. Why? Because if you stick it back in the original one and you put in a negative 70 something there, you'll have a negative base. You're not allowed to have a negative base. Those can't be negative. So even though you were smart enough to notice it's a plus and minus answer, one of these answers doesn't actually work. So hopefully you'll be really smart enough, and the kid who didn't even notice that just subtracts 3 or adds 3 to both sides and they get the right answer, and it's really sad because they didn't even notice that this one was there. A lot of the smart kids notice that oh, I should have 2 answers, but then they don't go far enough to check them, and then they find out that the extra answer they found doesn't actually work. And the kid who wasn't smart enough to notice it just happily says, I got the right answer. The other people noticed there was this other complicated answer. Hopefully you'll notice also that it doesn't work. Yes?
What if you put it as and then in constant section?
Ah, did you just say graph both sides and see where they cross?
Yeah.
Cool. As long as calculators would be allowed, absolutely works. Graph both sides and see where it cross strikes again. All right. Now, what did we focus on today? Where were the X's generally hidden in today's? In the base, yep. And we found them when they were X in the base. What kind will we learn next? Well, one of the other kinds, where it's not in the base, which could be the argument, or the other kind, which is when it's in the exponent or the answer. Yep. All right, cool. So this is your assignment, worksheet, day 3. I want to get those scores in that homework. We still have probably 10, 15 minutes. Unusual. You get actually time to work on your homework. So let's look at it together for just a second here. All right, so here's our worksheet. The first page isn't too bad. These are just like practice on, at the beginning, practice on making the bases the same. Like make that into a 9 or a 4/9 to a power. Remember, if you get stuck on these, you just say equals x and you rewrite it. 4/9 to the x equals 2/3, and then you go, the only way I can do that is if the bases are the same, and you might realize I could write that as a 2/3 to a power, and then you can solve it. And by the way, this 2/3 has a power of 1. All right, so I'd say I definitely want you to not skip any of number 1. Those are all important, probably the main thing actually from yesterday, but really, really important. Number 2, those are easy equations until you hit E as an elephant. That's when you'd have to do rewrites. This one's a get the clump alone. We practiced that like on F. So I want you to do all of problem 2. Problem 3. This one says without a calculator, so these are ones you can do a rewrite and you pretty much instantly get. Those will be pretty easy. But we got a lot in this last section here where I don't think we need that many. So I'm going to have you skip G and H and I, G, H, and I, G high, and I don't want you to skip the very last one. I want you to see you can actually solve really complicated ones like F. But I want you to skip E as an elephant. G high and E, the ones you can skip for today. If you want to see if you're like a superhero already at this, try solving F. This to the this equals that. Certainly not impossible. I will remind you that 14/12 will simplify. Makes your life a little easier. All right, that's all I have for you for today.